We're rolling. Back for the kill shot on this packet. Next up is is our first combustion reaction. What makes it a combustion reaction, or it was the fifth one listed on the PowerPoint down at the very bottom. You have a molecule of carbon and hydrogen. Carbon and hydrogen means hydrocarbon, which means you have oxygen, and your products are always the same. They're going to be carbon dioxide and water. You have a specific strategy for hydrocarbon reactions. Those are also called or combustion reactions. You have reactants and you have products. You start with carbon. So first element you want to balance is carbon. So you have 3 carbons here, which means you need 3 here, which means you have to put a 3 in there, and you've got carbon fixed. Your next element you want to tackle is hydrogen. So you look for your hydrogen source here, you have 8. So from here is your only hydrogen source on the other side of the street. What you need here is you need 8. So 2 goes into 8 4 times, or 4 times 2 gets you the 8. So hydrogen's fixed. And then the last element you want to worry about is oxygen. One thing when you're doing combustions, this O2 is always the last thing you'll adjust. Okay? Because you need to total up the O's on this side. 3 times 2, you've got 6 there. 4 times 1, you've got 4 there, which means you have 10. So what you need to make here, you need 10, but you have 2 in play. 2 goes into 10 5 times. So O, you have 10, and you have 10. That's how you knock out a combustion reaction. On to number, oops, we should formally type that. That is, before I nuke it, there's combustion. Okay, number 14. First up, let's type it. A plus B makes AB. That was number 1 on our PowerPoint. That was the first type of reaction we looked at. That was a synthesis reaction. So let's take a look here. Where do we want to start? Oh, I see it right now. It just popped out at me. We got a 2 on oxygen. We got a 3 on oxygen. We have a 2-3 scenario. So I take that 3, slide it up there. I'm going to take this 2 and slide it in there. Now I know oxygen's balanced because I have coefficient times subscript. I have 6 here, coefficient times subscript. I have 6 there. So the last thing I need to fix is Al, coefficient times subscript, which means I have 4 on Al. So what I need here is 4. The only way I can get 4 is put a 4 in there, and that one's done. And on to the last one on page 1. Number 15. Okay, let's take a look at this. First up, type it. Always type it first. If you remember, sometimes I forget, I want to jump right in and attack the balance. Type it first because that'll tell you what plan you might want to use an approach like an EO, or do you have a combustion reaction, which is a total plan by itself. Do you have a double? You're going to look for polyatomic ions. Of course, course, the easiest one to identify is decomp. Decomp has a single reactant. It's the only reaction on the 5 families that has a single reactant. In this case, I've got a hydrocarbon, I've got oxygen, I've got carbon dioxide, and water as the product. It can only be a combustion reaction, which means I'm going to set up my scoreboard and my plan of attack. There's my reactants, there's my products, just like we did in the other one. We're going to start with carbon. Carbon, we have one here, we have one here. No need to fix the carbon. I can put the blue one down. Okay, next up, I'm going to fix hydrogen. So hydrogen, I've got 4 here, and I'm going to come over here, and I've got 2. But what I need is 4. 2 goes into 4, 2 times, or 2 times 2 will get you 4, coefficient times subscript. So hydrogen's fixed. And like we said before, the last one, this O2 is always last, because I need to count the O's on my